Hi, today we are talking about section 8.7, writing and graphing inequalities. An inequality is a mathematical sentence that compares expressions. It contains the symbols less than, greater than, less than or equal to, or greater than or equal to. To write a word sentence as an inequality, look for the following phrases to determine where to place the inequality symbol. This symbol means is less than or is fewer than. This symbol means is greater than, is more than. This symbol is less than or equal to, is at most, is no more than. And this symbol is greater than or equal to, is at least, is no less than. So I like to think of inequalities, they're like equations, but they've got this symbol or any of these symbols rather than an equal sign. So it's telling you that one side of the equation is bigger than the other. Example 1, writing an inequality. A number C is less than -4. So we want to write this as a mathematical statement or a mathematical sentence using an inequality symbol. We just want to put this in symbols. So a number C is less than -4. Now this, I like to think of it as an alligator mouth. The alligator would rather eat an adult over a child because it is bigger. So the alligator's mouth wants to go towards the side that is supposed to be bigger. In this case, it's saying C is smaller than -4. So C is the smaller number. The alligator will want -4. A number K plus 5 is greater than or equal to, notice the equal to symbol is like half of an equal sign, to 8. Four times a number Q, so remember, we can just put those right next to each other, it shows multiplication, is at most 16. So this is showing that 16 is the biggest number that we can have. At most also means that it can include 16. I like to think of this in terms of money. If you say I have at most $5, it means that your number can be smaller than 5 or equal to 5. A solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution. The set of all solutions of an inequality is called the solution set. So for example, if we look back up at example 1, part A, there are many numbers that are smaller than or less than -4, like -5, -6, -7, and it keeps going forever in that direction for infinity. So when we have inequalities like this, please be aware that there is more than one answer typically. So here's an example of a chart. Can the value of x be 3 for this inequality? What you do, just like with equations, is you plug it in and you see if it's true. 3 plus 3 is less than or equal to 7. Yes, 6, 3 plus 3 is 6, is less than or equal to 7. That is a possible solution. Let's try 4. 4 plus 3 is 7. 7 is less than or equal to 7. that is also a solution because of the equal to portion of this symbol. Last one, 5. 5 plus 3 is 8. That is not less than or equal to 7. Therefore, 5 is not a solution. This symbol means is not less than or equal to when you put a slash through. It works the same with equal signs. So let's practice checking our solutions. In this inequality, we want to know if x plus 1 is greater than 7, if x can be 8. So we are going to replace x with the number 8 and just rewrite the whole thing. So I'm just replacing x with the number 8. Now I'm going to simplify this side and decide if the inequality is true. 9 is greater than 7, therefore x equals 8 is a solution. Now in the next one, 7y, 7 times y, is less than 27. So we're going to plug in y equals 4. Remember to put parentheses around when you have multiplication like this. We're going to simplify this end. And we need to check if it's true. Is 28 less than 27? No. So x, it should be y equals 4 is not a solution. Okay, next problem. 5 is greater than or equal to z divided by 3. We want to see if z can equal 15. So I'm going to rewrite this whole inequality, but replace z with 15. I'm going to simplify this side. 5 is greater than or equal to 5. The or equal to piece makes this true. Therefore, z equals 15 is a solution. Now that we've figured out how to check our solutions, we are going to graph. The graph of an inequality shows all the solutions of the inequality on a number line. An open circle is used when a number is not a solution. A closed circle is used when a number is a solution. An arrow to the left or right shows that the graph continues in that direction. So, I'm just going to go up here for a second. If I asked you to graph x equals 3, you would create a number line. You'd put 3 on the number line. And you'd put a closed circle on 3 to represent this number, x is 3. That is related to this. However, in an inequality, like I said before, you will typically have more than one solution. So we're going to show that in a different way on a number line. Okay, so for example 3, we are graphing y is less than -8. Now I'm going to show you the minimum requirement for these number lines and how to graph them. If you want to put more detail in, you are more than welcome to. First, you'll draw a number line. You'll put the number in the inequality on the number line. You will then decide if you should have an open circle if y can be equal to -8 or if y cannot be equal to -8. Now, as a trick for you, if it can equal -8, you will have a closed circle. And if it cannot equal -8, it will have an open circle. The way that I like to think about that is these two will have an open circle. These two will have a closed circle. The trick that I like to use is we have less writing for these inequalities, therefore we won't fill the circle in, less writing. For these, we have extra writing because of the or equal to piece of it, so we will have extra writing and fill in the circle. So in this case, we have less writing, it's not equal to, so we will put an open circle on the number line to represent that -8 cannot be equal to y. And then we have to decide which direction to shade in, toward the smaller numbers or the greater numbers. Well, in this case, y is less than -8. So y could be more negative. It could be -10. It could be -20 because it is smaller than -8. And those negative numbers are to the left on this number line. This is the minimum requirement for when you're graphing inequalities. All right, last one. Graph G is greater than or equal to 2. So we're going to draw our number line. We're going to graph our number on the number line. That's all you need to do. If you want to put more numbers in, you may. You're welcome to. And we know we have a closed circle on 2 because it is greater than or equal to. So we're going to have a closed circle to represent that G can equal 2. And then G is also greater than 2. So we want numbers bigger than 2, like 3 or 4. So I'm going to shade towards the right to represent that. I want you to notice that I am also shading over the arrow on my number line to show that it goes on forever. We just don't have the ability to actually draw that. So again, when we graph our solutions here, we know that it represents more than one number, which is why we're shading in a direction. This is covering over -9 and -10 and -11 and so on. This one is also including 3, 4, 5, and so on. So that is how you graph inequalities. And that is the end of our 8.7 notes.